Welcome to today's Explainer, where we're going to break down the incredible cellular science behind how our bodies combat physical decay and why a very specific marine compound might just be our absolute greatest ally. If you've ever found yourself wondering why our skin loses its bounce as we age, or why our muscles get incredibly stiff after we've been injured or bedridden, well, you are in the exact right place. We're going to explore the microscopic battlegrounds right inside your tissue, focusing heavily on how we can protect and synthesize collagen, which is literally the scaffolding of our bodies. Okay, let's dive right into this with a question that might seem a little strange at first, but it gets to the very heart of cellular aging and tissue damage. What do a severe sunburn from a beach vacation and a stiff, immobilized ankle trapped in a cast have in common? I mean, on the surface, they seem like completely different medical issues, right? One is an external radiation burn, the other is internal physical disuse. But at the cellular level, they are actually triggering the exact same destructive cascade. Whether it's ultraviolet radiation hitting your face or a cast immobilizing a joint, both of those external stressors trigger an explosive internal alarm, an absolute overload of molecular wrecking balls called reactive oxygen species, or ROS. Now, normally our body's master antioxidant, glutathione, keeps these in check. But under this kind of severe stress, our glutathione levels are rapidly depleted and just totally overwhelmed. The result? These free radicals relentlessly target and destroy your tissue's structural foundation, your collagen. And this disruption directly leads to what we instantly recognize as tissue aging in the skin and stiff fibrosis in the muscles. Section 1. The protector. Meet astaxanthin. So, what exactly is this protector? Astaxanthin is a remarkably potent marine antioxidant. It's actually a pigment derived from microalgae, specifically one called Heminococcus pluvialis, which turns blood red to protect itself when it's stressed. When we ingest it, it acts kind of like a cellular lightning rod. It absorbs the impact of those ROS wrecking balls we just talked about, safely conducting electrons away and neutralizing the free radicals before they can pierce your cell membranes and damage your cellular DNA. And the potency here is honestly staggering. We're looking at a 10-fold greater antioxidant capacity than lutein and a 100-fold greater capacity than alpha-tocopherol. It actively suppresses the NF-κB signaling pathways that cause all that inflammation. But absolutely crucial to our deep dive today, it downregulates MMPs. You can think of MMPs as biological scissors. They're enzymes that literally chop up your skin's collagen matrix. By suppressing these scissors, astaxanthin actively protects and promotes collagen synthesis, both in the lab and in living tissue. Section 2. The proof. Repairing photo-aged facial skin. Let's look at some real data. In this trial by Yuan and colleagues on UV-irradiated human skin, there is a massive spike in COL1A1. That's procollagen type 1. Astaxanthin supplementation induced a 3.4-fold increase in the creation of new collagen. And on the flip side, we see steep drops, a 68% and 77% suppression of MMP1 and MMP12. Remember, those are those collagen-destroying scissors. So the skin is quite literally shifting away from degradation and going directly into a state of active structural repair. But what does this molecular victory mean for you in the real world? Well, after 12 weeks of oral supplementation with astaxanthin and collagen hydrolysate, human subjects had significantly tighter, more elastic facial skin. They also saw a major reduction in transepidermal water loss, which simply means their skin's barrier was locking in moisture far better than before. And when we actually look at the histology, we can see this preservation visually. Without protection, you get obvious cellular damage after UV radiation. But in the treatment group, after 12 weeks, the structural integrity of the skin's dermal matrix is visibly preserved right against that UV onslaught. It's essentially an internal shield. Section 3. The proof. Cellular skin regeneration. Let's dig into the why. When skin cells are injured by UVB-free radicals, they basically hit a self-destruct button. Oxidative stress skyrockets, entirely depleting the cell's natural glutathione. Without that glutathione defense, collagen drops and inflammation executioner proteins, like caspase 8, 9, and 3, just skyrocket to cause programmed cell death. But when astaxanthin is introduced, this marine compound steps in to take on that antioxidant burden. It neutralizes the oxidative stress, suppresses those executioner proteins, and allows the cells to survive, which ultimately results in a massive increase in protected collagen synthesis. Section 4. The proof. Stopping skeletal muscle fibrosis. Now let's switch gears from skin to muscle.
This flowchart from the Mazawa study perfectly maps out the biological problem in skeletal muscle. Joint immobilization causes two simultaneous reactions, an overproduction of those ROS free radicals and an inflammation response that triggers a cytokine called TGF-beta 1. Now, TGF-beta 1's job is to promote the differentiation of fibroblasts into myofibroblasts, which dangerously overproduce collagen, creating stiff muscle fibrosis. It's way too much of the wrong kind of collagen. But look at the intervention point. Astaxanthin intercepts and effectively scavenges the ROS, breaking the cycle completely before your muscles can harden.
And you can literally see this fire being put out under the microscope. Using DHE staining, ROS free radicals glow bright red. An immobilized muscle is a fiery red storm of oxidative stress. But an immobilized muscle that has been treated with astaxanthin, it has completely quenched that dangerous cellular fire, bringing the oxidative stress right back down to normal, healthy baseline levels. Because that oxidative stress was neutralized, the downstream effects were entirely prevented. When we measure the actual proteins that cause muscle stiffness, those fibrotic proteins like TGF-beta 1 and alpha SMA, we see that astaxanthin successfully suppressed their buildup. It literally stops the muscles from turning into stiff, fibrotic tissue.
Section 5. The big picture. The collagen connection.
So this is where it all comes together. The shared villain in both skin wrinkling and muscle stiffness is oxidative stress, dictating the fate of your collagen. In your skin, ROS activates biological scissors to destroy healthy collagen, causing sagging and wrinkles. In your muscles, ROS activates a panic response that overproduces tough, fibrotic collagen, causing stiffness and a loss of mobility. By quenching the ROS, astaxanthin acts as a master regulator, saving the healthy collagen in your skin while preventing that stiff collagen buildup in your muscles. I want to highlight this quote directly from the CHO study because it beautifully summarizes our entire explainer today. These positive results show that astaxanthin repairs tissue injury and aging by conducting electrons out of cells to maintain a low level of oxidative stress so that collagen is synthesized. It's just elegant in its simplicity. By acting as a cellular lightning rod, safely conducting harmful electrons out of the way, it allows our body to do what it does best, maintain the strong elastic structural integrity of our entire physical form. So, I leave you with this final thought to ponder regarding your own nutritional and cellular health. Every single day, whether it's through the sun on your skin, the physical stress on your joints, or just the natural process of aging, your cells are under attack. Are you providing your body with the armor it needs to protect its foundation? Think about it. Thanks for joining me on today's explainer, and I'll see you next time as we continue to decode the incredible science of the human body.